Okay, so let's have a look at this question. Taxi companies charge for a single taxi journey, and you have a particular formula here. This is C equals 2.8 plus 1.6D. If we compare it to Y equals mx plus C, that will be cost equals 1.6 times by D plus 2.8. So you can see maybe how these are connected. That will be the y-intercept, and this is the gradient. Okay, so let's just see how this will work. It says draw a graph of distance against cost for any journey up to 8 kilometers. So maybe you could actually just do a little table of values. This is distance, this is cost, maybe 0 and 8, because you know it's a straight line. So 0, when you substitute in, you should see clearly that it's going to be 2, oh, my bad. 0, when we substitute in, the cost will be 2.8. So it's charging you 2.8 for travelling 0 kilometers. Well, that's just a call out fee or a flag down rate. And then for 8, we just substitute it in. We can use our calculator to do that. So we will do that now. Over here, let's do doc, insert a calculator, and we want to do 1.6 times by 8 plus the 2.8. There you go, 15.6, and we've got 15.6. So with those 2 points, that's all we need, right? We need 0 with 2.8. 0, this is 1, 2, 3, so 2.8. Again, it's just maybe a best guess. And then here is 8 with 15.6. So again, we go 5, 6, 7, here's 8, and 15, 16, there's 15.6 is there. And then we connect with a straight line. So we just try and join it. And that's your graph, okay? So it starts at 0k, we include the 0k, it finishes at 8 kilometers. We might put in the coordinates 8, 15.6. So we know what's going on there. Then we always have to label the variable, distance, and then the units are important, right? Distance, and then over here, it's a UK question, cost in pounds. And that's the full description of the graph. Okay, state what the value of 2.8 represents. Well, 2.8 represents 2.80. For sure it's the cost in pounds, but this is the cost for 0 kilometers, so y-intercept, but basically try and translate that into what does it really mean. It's the call out cost, right? If you order an Uber and then you cancel it, you're going to be charged a cancellation fee, aren't you? Okay, and then part C, let's get that one done as well. At 1.6, well, you can clearly see that the way we've drawn it, this is the gradient. So the gradient is a rate of change. So we need to think it's the rate of change of cost for distance. So it's pounds per kilometre. So this is 1.6 is the cost per extra 1 kilometre. All right, so it's cost for every extra 1 kilometre drawn, 1 kilometre driven. D, state the range of the graph. All right, so the range is the y values. So basically you're looking at this value all the way up to this value, and we use the C and we use the inequality signs. We look at the lowest price, which is 2.8, and the highest, which is 15.6. And finally, E, use your graph or otherwise to find how far a passenger could travel by spending 10. So $10, we could actually use the graph and get a rough idea, right? That, the way we've drawn the graph, could be maybe 4.5 kilometers. So let's just write that down from the graph. And D equals 4.5 kilometers. But we can also work out from the equation, right? The equation is C equals 2.8 plus 1.6D, and the cost is 10, so we substitute 10 in. We subtract 2.8 from both sides, we get 7.2 equals 1.6 d, and when we divide by 1.6 to get d, we do in fact get 4.5. So d is 4.5 kilometers, right? So that's basically all of the question done just by not a calculator graphing method. Maybe use the calculator to do some numbers. But let's again try this with the TI Nspire. So let's get this big screen. And if I go doc, insert a graph, and just go ahead and type in the equation, which you might remember is 2.8 plus 1.6x. And I mean, obviously our graph wants to start at x is 0 and finish at x equals 8. So we can go and label that. So what you can do now is you can press Ctrl G to go back to the graph, or press Tab. Okay, once you press Tab, press up, you go back to the equation. And now we're going to restrict the domain. So we're going to make a little fancy maneuver here. Above the equals, you've got an extra toolbar in red, Control equals, and it's this line we need. Given that 0, and then back into that magic toolbar, less than or equal to x, less than or equal to 8. So this is how to restrict the domain, the x input. And when we press go, can you see what we've done there? If we just change the scale now, let me maybe go do it manually. Menu, window zoom, window settings. The x I'll go -1 up to 10, and y I'll go -$1 up to 20. And there we go, we've got that beautiful graph, okay? And yeah, it's nice to see it here, but now we can solve part E. How far would you travel for $10? So if we press tab again and we type in 10, you see that's the cost of 10. So it's like using the graph but more accurately. And then we go menu, analyze graph, intersection, click before, click after, and there we go. We've got 4.5. Now, interestingly enough, if you wanted to transfer that down to your working out, what you would do is you would try and just sketch the graph like this. This is x and y. You'd have a nice little picture here. You'd have this here. You'd maybe say this is y equals 10. And then you just have this 4.5. This would be your working out. And then you would have d equals 4.5 kilometers. And that's perfectly fine for showing your working out if you've used a graph on your calculator.